Greggory DeVore. I'm a maternal fetal medicine specialist. I practice in Los Angeles, California, and I have a real interest in fetal echocardiography. We use a technology called speckle tracking. And speckle tracking is an approach in which, by tracing the endocardium and systole and diastole, the software tracks the movement of the pixels, which represent movement of the endocardium of the heart. From that, originally, speckle tracking was used to measure only 4 elements of the heart in the adult and pediatric population. The first was strain, the second was strain rate, the third was velocity of movement, and the fourth was displacement. And then they divided it up into 3 segments: the base, the mid, and the apex. So those are the 4 measurements that one obtained. The unique thing about Fetal HQ is that we've taken the measurement, the raw measurements, the movement of the pixels, so to speak, and we've extrapolated much more information than simply those measurements I just mentioned. We've been able to measure, for example, 24-segment diameters, 24-segment fractional shortening. We've been able to measure the area of the heart. We've been able to measure the strain of the entire ventricle or the lateral and septal wall strain. We've been able to measure cardiac output of the left ventricle. So we've taken these raw measurements that was used in speckle tracking and extracted much more information than even what's available in the adult or the pediatric world, so to speak. That's because we dissected into the program itself, found out what the component parts were that we're measuring, and then extracted from that more information. What's unique about Fetal HQ is we've actually constructed the concept from the ground up. What we initially did was we took the measurements that are part of Fetal HQ and published papers using 200 controls, and also we used various types of pathologies to illustrate the principle. So we built a foundational concept, and all of these papers have been published. So in the literature, they've been peer-reviewed, of course, extensively, and then we've taken those studies and implemented them into Fetal HQ. Instead of just giving you a raw measurement, for example, if here's the diameter, 24-segment diameters of the heart, we've said here's the 24-segment diameters that you measure in a fetus, but because we have control data, we're able to take and create a distribution, for example, 1 or 2 or 3 standard deviations. We're able to compute z-scores, because that simply requires the mean and standard deviation from a control population to compute a z-score. We're able to convert the z-score value, which always has an equivalent percentile value. We've displayed that so the user gets quantitative information compared to a normal control group, so they can help them understand what's abnormal in the fetus that they may be studying. So this is really important because most papers will report the normal values but don't really provide the z-scores or the graphical display of the standard deviations, and so it's hard to put it all together, whereas this program has it all in one place. Now this represents what's called the landing page, or the first thing that you see graphically. As we toggle down, then this is a summary of the 4-chamber view size and shape. The next is a summary of the ventricular size and shape. And finally, we have a summary of contractility. Again, you can take and click on the individual 24 segment right here and see it displayed. What we have on the summary page is we simply have segment 1, which represents the base of the heart, and segment 12, which is the mid portion, and I'll show you on this graphic. It's represented here. Here's segment 1, and then segment 12 is located here. So we've just picked out the base and the mid segment for a quick analysis, and by clicking the button you get the full 24 segment analysis.